Hello, welcome to today's class. Today we have to take wave lecture 7. In this chapter, we have already gone through many things like stationary wave, progressive wave, difference between the stationary and progressive wave, etc. Now, this time we will discuss the open and closed organ pipe. We have already defined what is closed pipe and what is open organ pipe. That they are just metallic pipe with either both the ends open or one side is closed, one side is open. Okay, and that we call as organ pipe. For example, suppose we are having this is a hollow cylindrical pipe. It is in fact aluminum pipe, a little bit thicker. This could not be an organ pipe, but this could be behave like an organ pipe. If I have this, you can see this type of sound. You can get frequency of some sound. And if I hold a lower portion and that is closed, and again do the same thing, you can get the difference of the sound. Difference of the sound means difference of the frequency. Again I am talking about this. Suppose I am holding it here and here. It is both the end open. It is open organ pipe situation. And if we take this one and I am holding the lower portion and again I am doing the same thing, the frequency is different. Okay, and how they are actually mathematically different, how the calculations are made, that we have to discuss today. First we have discussed the closed organ pipe. Closed organ pipe. Organ pipe. I am taking three different cases of the same organ pipe. In the first possible vibration, what happened? One wave would come and meet here, and it is reflected back, and somewhere it would move like this. We have to remove this portion, but rather for your information I must tell you one thing, that at the open end the only antinodes are formed. Antinodes means maximum displacement, you can see maximum displacement, and at the rigid end, that is closed end, we have only nodes. This is node and this is antinode. That means if it is the L is the size of the tube, then we can have for the first possible vibration, we have one antinode and one node. तो एक नोड और एक एंटीनोड के बीच का डिस्टेंस कितना होता है? लैम्डा बाई 4. तो ये लैम्डा बाई 4 अगर इस जो साउंड वेव या वाइब्रेशन जो आ रहा है उसका कितना वेवलेंथ है? लैम्डा. देखो L इक्वल टू लैम्डा बाई 4 और लैम्डा इक्वल टू 4L. लैम्डा इक्वल टू 4L. The corresponding frequency of air column equal to how much? Equal to n equal to कितना हो जाएगा आपका? V upon lambda, and this is V upon 4L, where V is the velocity of sound, velocity of mechanical wave. This is the case of first possible vibration. You can see here we are having only single pipe, that is a closed organ pipe of length L. I have taken a closed organ pipe of length L, and in the first possible vibration, of air column, because whenever I am just doing something so that the air column confined in the pipe is vibrated, in first possible vibration, one antinode and one node is formed, and their distance between them is lambda by 4. It is due to the vibration of air column, remember. And then we have N1 equal to the first possible frequency of the air column is V upon 4N. Okay. Now I am writing down here N1 equal to V upon 4N. Now I am removing this. Okay. Now for the second possible vibration, what will happen for the second possible vibration? N2 node is always at the open end, and at the close end there is always a node. This is node, this is empty node, this is again node, this is empty node. That means in this case we have two. The second possible vibration, we have two empty nodes and two nodes. ये इक्वल नंबर में होगा, देख सकते हैं यहाँ पर नोड्स की संख्या भी दो है, एक और ये एक दो, और दो एंटी नोड है। याद रखने वाली चीज है कि जो भी वाइब्रेशन हो रहा है एयर कॉलम में, इवन मैंने इसको भी जैसे मैंने बजाया, इसको भी जैसे मैं बजाना चाहता हूँ, you can see this type of thing is there, and when I just close the pipe, the sound is different. I am discussing only that situation when we are discussing the closed organ pipe. Okay, one end close. Here, the second possible variant, there are two nodes and two antinodes, and length is again L. This is lambda by 4, lambda by 4, lambda by 4. That means we have L equal to 3 lambda dash by 4, and therefore imply that lambda dash equal to 4 L by 3, and N2 equal to V upon lambda dash, that is 3V upon 4 L. This is your second one. N2, that the next frequency is your 3V upon 4L. Velocity of sound in any medium is constant. A length of the pipe is also constant. That means N1 and N2 both are constant for a given pipe. Okay, ये दो चीज आ गया. Now in the case of third possible vibration, देखिए इसमें एक नोड एक एंटीनोड आ रहा था, इसमें एक दो नोड और दो एंटीनोड आ रहा है. हर केस में ओपन एंड में एंटीनोड और क्लोज एंड में नोड बना रहते हैं. यहाँ पर नोड बनेगा, यहाँ पर तीन तीन बनना चाहिए. इन दैट वे वी कैन जस्ट राइट this is node, antinode, node, antinode, node, antinode. Here again we can see the wavelengths are decreased and the frequency is correspondingly increased. Here we can see that we have the three nodes and three antinodes. So in the third possible vibration, the वही चीज हम लिखेंगे. In the third possible vibration, we have both three. There will be three antinodes and three nodes. Okay, and with the effect of which इसका डिस्टेंस कितना होगा, लैम्डा बाई 4. एक एंटीनोड और दूसरे नोड के बीच डिस्टेंस कितना होता है, लैम्डा बाई 4. क्योंकि दो एंटीनोड्स के बीच का डिस्टेंस लैम्डा बाई 2 होता है और दो nodes के बीच भी lambda by 2. Distance between two consecutive antinodes is also lambda by 2, and distance between two consecutive nodes are also lambda by 2. But distance between one node and nearest antinode is always lambda by 4. So here lambda by 4, lambda by 4, lambda by 4, lambda by 4, lambda by 4. 5 lambda by 4. That means here we have L equal to 5 lambda double dash upon 4, and here we have N3, and naturally it must be a 5. Okay, and here we have, this is 5 lambda double dash, and this upon this will be equal to 5V upon 4L. Therefore N3 comes out to be 5 3/4L। तो ये तीन में आपने एक सिस्टम देखा, एक हार्मोनिसिटी देखा. While observing just three frequencies, three different frequencies, we can see one harmonicity over here. That is, the frequencies are harmonically mentioned. Okay, that means the possible frequencies of ear column vibration, and across tube are harmonically arranged, and the ratio of their frequencies how much it is, 1 is n1 is to n2 is to n3 is to n4 n5. Sorry, here we won't write like this, but one thing we can see that they are actually different type of thing. N1 is to n2 is to n3. We call them as n1 is to n2 is to n3 is to n4 dash equal to 1 is to 3 is to 5 is to 7, 9, and so on. That means such things are only taken in odd series, that is 1, 3, 5, 7. If such vibrations are called harmonics, if such periodic vibrations are called harmonics, then we call N1 as frequency of first harmonic. ध्यान देने वाली चीज है, N2 is not frequency of second harmonic, but rather it is frequency of third harmonic, because harmonics are taken according to this ratio. And what we have said, the possible frequencies of ear column vibrations in a closed pipe are harmonically arranged, and the ratio of their frequencies are distinct. Ratio of their frequencies are this much. Okay, and if such periodic vibrations are called harmonics, then we call N1 as the frequency of first harmonic, N2 is the frequency of third harmonic, N3 is the frequency of fifth harmonic, so on. That depends on the ratio, not their serial number. यानी कि 1 के बाद 2 आएगा फिर 3 आएगा, ऐसा नहीं है. जैसे उनके फ्रीक्वेंसी का रेशियो होता है उसके हिसाब से हार्मोनिक का रेशियो भी होगा. The ratio of their harmonics will always be according to the ratio of their corresponding frequencies. तो ये corresponding frequency का ratio हो गया. So this is why N1 is the frequency of first harmonic. Similarly, N2 is frequency of third harmonic, and so on. Frequency of third harmonics and so on. तो ये चीज अगर मैं ये कह दूं कि frequency of first harmonic जो होता है, that is the least possible frequency of vibration. जो पहला फ्रीक्वेंसी जो होगा, द स्मॉलेस्ट फ्रीक्वेंसी जो होगा, दैट इज द फ्रीक्वेंसी ऑफ लीस्ट पॉसिबल वाइब्रेशन. लीस्ट पॉसिबल फ्रीक्वेंसी जो होगा, दैट वी कॉल एज द लीस्ट पॉसिबल फ्रीक्वेंसी and an organ pipe is called as fundamental frequency. Fundamental frequency. तो यहाँ पे कौन सा फ्रीक्वेंसी है? यहाँ पे फ्रीक्वेंसी ऑफ फर्स्ट हार्मोनिक जो होगा वही फ्रीक्वेंसी ऑफ फंडामेंटल फ्रीक्वेंसी भी कहेंगे, और बाकी जितने फ्रीक्वेंसी होगा सबको हम लोग ओवरटोन्स कहेंगे, फ्रीक्वेंसी ऑफ ओवरटोन्स। तो एन ये है आपका, दिस इज योर N1. N1 is the least possible frequency in an organ pipe. ये organ pipe यहाँ पे तो क्लोज चल रहा है, तो यहाँ पे क्लोज organ pipe चलेगा, वैसे ओपन के लिए भी होगा. This is for closed organ pipe because we are discussing closed. तो ये आ जाएगा, and this is your this one, and N2 is called frequency of first overtone. First overtone. तो ऐसे चलता रहेगा, फ्रीक्वेंसी ऑफ फर्स्ट ओवरटोन, फ्रीक्वेंसी ऑफ सेकंड ओवरटोन एंड सो ऑन. इसी चीज को फ्रीक्वेंसी ऑफ फर्स्ट ओवरटोन का हमारे क्या बताया था? फ्रीक्वेंसी ऑफ थर्ड हार्मोनिक, क्योंकि रेशियो वाइज तो हार्मोनिक्स वाइज जब बताएंगे तो रेशियो जब हार्मोनिक्स फर्स्ट हार्मोनिक थर्ड हार्मोनिक फोर्थ हार्मोनिक बोलेंगे तो उसके फ्रीक्वेंसी को उसी आगे बताएंगे, तो वो रेशियो होगा 1 2 3 नहीं होगा वहाँ, यहाँ पर पहले के बाद सीधा तीसरा आ रहा है फिर पांचवा आ रहा है, तो व्हाट वी कॉल frequency of first harmonic, frequency of third harmonic, frequency of fifth harmonic, like this. But when we call the tone, this is your called fundamental tone frequency. Fundamental frequency or fundamental tone frequency. And similarly, N2 is called frequency of first overtone. ठीक है, and N3 is frequency of second overtone or frequency of fifth harmonic and so on. And in that way, we have seen what is the working of this closed organ pipe. It has many musical instruments which can work on the principle of this closed organ pipe. And for that, I can just show you one of such examples also. Suppose this is a flute which has no hole at all. Only one thin rod is bamboo rod is there, and there is one hole where from where we just blow the air. Initially, when we keep this length, this is considered to be a zero air column. There is no sound, no sound. But when we increase the length of the air column, I have increased the length, you can get the sound. Now I am further increasing the length, the frequency is changed. I am again increasing the length, frequency is further changed. And if I further change the length of the air column, I am increasing the length of air column, frequency is changed. Now if I just keep on changing the frequency, then music will be created. Now, this type of music is created. That means we can very easily assume that how exactly, practically, this closed organ pipe is held in our day-to-day life. So, after this, we will move to the open organ pipe. Okay, one thing before we complete the closed organ pipe, one thing we can very easily conclude that a closed organ only odd harmonics are possible in a closed pipe. After that clear? N1 is to N2 is to N3 कितना 1 is to 3 is to 5. So only odd harmonics are possible in closed pipe. तो अभी आपने प्रूव करके देख लिया. And we will discuss now the open organ pipe. Open organ pipe. Here both the ends open. Again, I am taking 3 different samples. As we have said, in open area, there is no node. Only antinode is formed in the open area. Okay, now we can have one antinode and another antinode over here, one antinode and another antinode over here. Therefore, there are 2 entry nodes 1 node. And second possible vibration, we have this type of thing: entry node, node, entry node, node, entry node. And third possible vibration, we can see entry node, node, entry node, node, entry node, node, and entry node. Else, else, else. तो यहाँ पे कितना हो जाएगा? देखिए 3 एल है यहाँ पे, 3 आपका पॉइंट से 1 2 3, दैट मीन 2 एंट्री नोड्स एंड 1 नोड. Here we have 3 entry nodes and 2 nodes, and here we have 4 entry nodes, 1 2 3 4 and 3 nodes. 3 First we have 2 entry nodes and 1 node. Second one, we have 3 entry nodes and 1 node, sorry, 2 nodes. And in third case, we have 1 2 3 4 4 entry nodes and 3 nodes. No need to write separately that is in first possible vibration, second possible vibration, third possible vibration. We have already said in previous lecture that organ pipes are actually metallic pipes with either both the ends open or one end is open. If both the ends open, then it is called open organ pipe. If one end is open, then it is called closed organ pipe. Now we are actually discussing the open organ pipe. Therefore, you can see I have taken an open organ pipe of length L, and these are the 3 possible vibrations. Okay, and one by one I will take. For this one, you can see distance between distance between one entry node and node is how much? Is lambda by 4. So lambda by 4 plus lambda by 4. So 2 lambda by 4 हो गया. Then first possible vibration we have L equal to 2 lambda by 4. There is lambda by 2. Lambda by 2, or in general what we have, the frequency, lambda equal to 12, and the first possible frequency or the frequency of fundamental tone कितना हो जाएगा? N1 equal to V upon lambda V upon 12. Yeah, first case. This is the case 1, first case. First case में ये रहेगा. Now we take second case. Second case, lambda by 4, lambda by 4, lambda by 4, lambda by 4. We have 4 lambda by 4. That means L equal to 4 lambda dash by 4 or lambda dash equal to L. That means N2 equal to V upon lambda dash equal to V upon L or 2V upon 12. This is our second case, second possible vibration when we have 3 entry nodes and 2 nodes. ये आपको बार बार बता रहा हूँ कि हमेशा ओपन एंड में क्या होता है कि एंटी नोड ही बनता है और क्लोज एंड में नोड बनता है, तो उसी हिसाब से चल रहा है यहाँ पर. तो यहाँ पर थर्ड पॉसिबल केस में क्या हो जाएगा? एंड थर्ड केस we have you can see 1 2 3 4, there are 4 entry nodes and 3 nodes. That is L equal to lambda by 4, 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 lambda by 4. 1 2 3 4 5 6 हो जाएगा. So this is equal to 6 lambda double dash by 4, or in that case lambda double dash equal to 2 by 3 L, or n double dash or n3 equal to V upon lambda double dash, that is equal to we have V upon 3V upon 12. We have 3V upon 2L. Okay? So in that way we have seen three different cases. N1 equal to V upon 2L, N2 equal to 2V upon 2L, and N3 equal to 3V upon 2L. तीन अलग अलग होंगे, इनके बीच का रेशियो क्या हो जाएगा 1:2:3. What we have the ratio that is this one, N1:N2:N3. कितना रेशियो आ जाएगा, N1:N2:N3 is 1:2:3. That means all the possible harmonics are possible. That means here even and odd both type of harmonics are possible. In an open file, all harmonics are possible. All harmonics are possible means odd plus even दोनों हो सकते हैं. Odd plus even. Odd plus even. Both types of harmonics are possible, and we have seen this is a very unique thing, and by this we have in fact completed this portion, that is the vibration of air column. And next we discuss a very little bit about the vibration of stress string, and that we can take even in our next round of lecture. वाइब्रेशन ऑफ स्पेस की जो हम लोग नेक्स्ट लेक्चर में देखेंगे, और कुछ चीज़ में ज़्यादा कुछ देखना नहीं है, छोटा मोटा चीज़ है, इट इज़ नॉट अ वेरी लार्ज थिंग. And after which we will take the beats. Therefore, in next lecture we will basically discuss beats along with the remaining portion of this, that is vibration of stress string. With that we have completed today. Thank you.